again, you all are welcome to your own channel, Geography for Success. And in this video, we are going to continue with the second part of the topic, insolation. And in the first part, we have already discussed about what are the various methods of transmission of heat, insolation, terrestrial radiation, solar radiation, all these. And along with this, the various factors which influence the distribution of temperature in different parts of Earth. Okay, so these things we have already covered in the first part of this topic. Now we have to discuss about heat budget, which is again a very important part of the topic insolation. Okay, so let's start with it. And before I start, I must remind you once again that if you like this video and you feel that it is going to help you in your studies or your preparation for your competitions and all, so don't forget to subscribe the channel and share the video with your friends also. Okay, so let's start with it. First of all, heat budget, right? What is heat budget? Budget, the term means when we prepare an estimate of total income and the expenses, what we are going to have, right? So when we prepare a plan for that, that is called a budget, where all we are going to spend the total amount of income what we are having. Okay, so these all things are all together when we plan all this, that is called a budget. Clear? The same thing, same term if you apply here, heat budget, that means what? It is not a budget of money or the total income and all. Here we are talking of the heat, right? And the heat, from where it's coming? Solar radiation. Because solar radiation is the only source of heat what we are getting, only source of you can say the heat energy what we are getting from the sun all over the earth, right? Now when the solar energy, solar radiation, okay, solar energy comes to us in the form of radiation. Clear? And when it comes to us in the form of radiation, it is always received on the earth in the form of, yes, insolation. Whatever amount of it is reaching on the earth's surface, that is called insolation. Clear? At the night time, when there is no solar radiation coming to us, now it's the time when the earth, when it is getting, suppose during daytime, whatever heat it has got from the solar radiation, now this heat is given back by the earth at the night time, right? And this is called as the terrestrial radiation. Okay, solar radiation, the radiation given out by sun, right? And terrestrial radiation, the radiation given out by earth. Now let's talk about it. Always, you know, children, it is must, it is always considered that whatever amount of heat which is coming to us, equal amount of it should go out of the atmosphere of earth also to the outer space. Okay, what is the importance of it? Try to understand. The importance of it is that, suppose whatever amount of heat we are getting, in the beginning, let's take that as 100% is coming to us in the form of solar radiation. Okay, and when it comes to us, and after the, suppose whatever it is, amount of it is absorbed by atmosphere, or it's going back to the space, or some part of it is absorbed by the earth's surface. Clear? This total amount should be equally given out back by the earth's surface or by the earth's atmosphere. If there is an imbalance, that means the total amount of heat which is coming to us, right, incoming and outgoing, if it is unequal, then there is going to be a very severe condition. You can say it's going to be a very high temperature which is going to develop as a result of it, or it can be a very cold condition which is going to develop, right? And then again it will be not suitable for the existence of life. Clear? So always actually for the survival of life, it is considered that it is always proper that the balance is maintained between incoming and outgoing heat on earth, or the radiation on earth, right? Now let's start with it. First of all, let's talk about this. Suppose this is one line I have drawn here, and below this it is, suppose, Earth's crust. Clear? And this line is another one I have drawn, and it is showing the atmosphere over the Earth's surface. Clear? Now if we say that the total heat what is given by the solar radiation is 100%, let's take it as 100%. Clear? Now the incoming, okay, this is incoming, and it is always 100%, right? Out of the total 100%, some part of it reaches to the atmosphere, and from the atmosphere it goes back to the outer space. It is reflected back to the outer space. So this is what amount of it is actually reflected back directly. It is exactly 35%. Okay, clear? This is one part. Another part of it is actually coming to us, and it goes straight, and from the atmosphere it is absorbed by the atmosphere, you can say, right? Now you can see, children, when the solar radiation comes to us, right, solar radiation in total is 100%. Okay, 100% of it is coming to us, to the Earth's surface. Now out of the total 100%, you can see here 35% is there, which is actually reaching to the outer part of the atmosphere, and it is again reflected back to the outer space, right? From the atmosphere it is reflected back to the space. Clear? This is 35%. Next 14% is coming to the atmosphere. Okay, next 14% of the total solar radiation comes to the atmosphere, and it is absorbed by the atmosphere. Okay, clear? After that, what is left out of 100%? See, 35 plus 14, how much is that? This is 49%. Okay, so what is left now? 51% is left. This 51% comes directly to the Earth's surface. Okay, children? Now when it reaches to the Earth's surface, this is actually received by the Earth. This is absorbed by the Earth. And this is only called as the incoming solar radiation. Okay? This is called incoming solar radiation, or we also call it insolation. Okay? So total how much part of the solar energy or the solar radiation is coming to us in the form of insolation? Only 51% of it. Right? So I hope this much part is clear to you. 100% is coming to us in the form of solar radiation in the beginning. Right? Now come to the other parts of it. 35% of which is actually, when it reaches to the atmosphere, it is given back to the space. Right? It is reflected back to the space. That is 35% of it. Then 14% of it is actually reaching to the atmosphere, and atmosphere absorbs that 14% of it. Clear? Now what is left with us? That is 51%. Now this 51% of the total solar radiation reaches to the Earth's surface in the form of insolation, or it is also called as incoming solar radiation. I hope this much is very clear to you all. Yes? So this is just, this is just one part of it, right? Now let's see how it is actually going back and how much part of it is able to go back to the space, right? Now let's see the other side of it. Suppose just now I said that 35% of it is actually reaching to the atmosphere and it is going back to the space, right? Now this is going back to the space, clear? And how much is that? 35% of it. Okay, the same thing what I have mentioned just now in the earlier part, 35% comes and it is reflected back directly to the space. Okay, this is one part of it. Now the next thing is the atmosphere, children. If you remember earlier, we have already discussed about it. The atmosphere is mainly heated by the terrestrial radiation, okay, which is in the form of the long waves. Always the atmosphere is heated up more by the long waves, or you can say the long wave radiations, which is terrestrial radiation given out by the Earth. Clear? Now here what happens? Here some part of the heat is absorbed by the atmosphere by this source, that is what is coming from the sun, directly from the sun, or you can say the solar radiation. Just 14% of it is absorbed by the atmosphere, right? Now rest of it is absorbed from the terrestrial radiation, which is given back by the Earth's surface. Now you can see here, children, this is how much 51% has been received by Earth in the form of insolation. Okay, once it gets 51%, naturally it will be giving back also 51% only. Yes, whatever amount of heat it is getting, the same amount of heat will be given back by the Earth to the atmosphere or to the space. Okay, so this is 51%. That means it is going to give back the 51% again, right? Now let's see. Now in the form of terrestrial radiation, two things happen, children. One thing is, when from terrestrial radiation some part of the heat is actually absorbed by the atmosphere, right? And this is how much heat? This is actually 34% of it. This is 34%. Clear? 34% of the terrestrial radiation is actually absorbed by the atmosphere. Now, if we minus 34 from 51, how much we are getting? It is exactly 17%. Right? Now, where does this go? 17% of the heat. Now, you can see here, rest of the 17% of the heat is going straight to the space. Now, it is actually coming from the terrestrial radiation. Okay, this is actually coming from the terrestrial radiation. You can see here, it is combined forming how much? This is 51%. 34 plus 17 makes 51%. Got it? Now, what about the total amount of heat which is absorbed by the atmosphere? 14% it has got from the solar radiation, right? 14 plus this 34 which it is getting from the terrestrial radiation. Okay, so how much heat it is getting in total? 48% of the heat it is actually getting from both the radiations. Again I am repeating, atmosphere of Earth gets the total heat 48%. This is actually 14% from the solar radiation. You can see here this one, right? And it is absorbed by the atmosphere, and a major part of it is absorbed from the terrestrial radiation, that is actually 34%. Now when we total it, 14 plus 34, that makes 48%, right? And this is the total heat which is held by the atmosphere. Clear now? And this 48% is slowly and slowly, it again goes back into the space, right? It is released by the atmosphere slowly and slowly. So let's see whether the outgoing total heat in the form of outgoing radiation is getting 100% or not. Let's check that. Okay. Now here you can see 35%, right? 35% plus 17%. How much is that? When we total both the values, how much we are getting out of it? Yes, 52%. Clear? Now this is 52%. And after that, when we add this 48% of the atmosphere, okay, so 52 plus 48, how much we are getting out of it? It is exactly 100%. Okay, so this total, again, all these three, when we total, it comes again to the 100%. That means what, children? 100% we are getting as the incoming radiation, and equal amount of it is going back to the space in the form of outgoing radiation. Clear now? And this is exactly what we call as heat budget, right? You can see very clearly all the distribution of incoming amount and outgoing amount has been done. A plan has been formed, just like the budget what we make for, you must have heard about that. At homes also we generally prepare a budget, or the governments actually have their own budgets related to the total revenue and the expenses and all. Same way, I told you in the beginning that here also, if we apply the budget term along with heat, that means what does it indicate? The total heat what we receive in the form of incoming radiation and outgoing radiation. Okay, there is a balance maintained between the two. Okay, and where it is distributed in different ways, that is actually when we prepare the complete study of it, or when we prepare a plan of it, how it is getting distributed, that is actually called a budget, right? When we are talking that in the sense of heat budget, it is totally about the incoming radiation and outgoing radiation, right? The other way we can say the total amount of heat which comes to us in the form of solar radiation, right? 100%, and the total amount of heat which is going back to the space, that should be 100%, right? There should always be a balance between the two. Okay, if this balance get disturbed anyhow, there will be a big question mark in front of the existence of life. Okay, so that's why it is very, very important for us children. I hope this much is clear to you all now. Okay, so heat budget, this topic is now very clear to you, right? If you feel this video is helping you out to understand this topic, right, then you can share this video with your friends. Okay children,